This video is about the sorting algorithms that you need to know for the exam: bubble sort, insertion sort, and merge sort. So the bubble sort algorithm is basically used to sort an unordered list of items. So you've got loads of items in a list and you need to sort it into the right order. The algorithm is pretty simple to follow, but it can actually take quite a long time to sort out a list. Essentially what you have to do is follow the steps for bubble sort. You have to look at the first two items in the list. If they are in the right order, then you just leave them as they are. If they're not in the right order, then you swap them round. Then what you do is move to the next pair and repeat step 2. Then you keep moving on until you get to the end of the list. Basically, when you get to the end of that step, you have to do another pass to make sure that it's okay. So in other words, you do the first pass. If it's all in order, great. If they're not all in order, you do the same process again, and you keep repeating it until there are no more swaps to be done. It's really easy when you look at a worked example to understand how it's done. So if we use this particular list of numbers, they're not in the correct order. What we've got to do is compare the first bubble. So we look at the first two numbers, 64 and 24. You imagine a bubble is drawn around those. Compare them, and you know that to get the order into the lowest first, 24 needs to go before 66. So we swap 24 for 66, and that one's in the right order. Then you look at the next pair. So once the numbers are swapped, you compare the next set. You compare 36 and 66. 36 needs to swap round. Then you do the next set, 66 and 12. That needs to swap as well. Then you do the next pair, 66 and 90. They're in the right order, so you leave them as they are. Then we do 90 and 52. They need to swap, so you swap them over. Then it's a good idea to write what the numbers are like at the end of the first pass. By actually writing end of first pass, you're likely to get the mark for showing that you understand how the algorithm works. So once you've done that first pass, you're best writing out the numbers in the new format, so the order that they're now in. Then we start the algorithm again. So we compare the first two numbers, 24, 36. We don't need to swap them. We compare 36 and 12. They do need to swap. 36 and 66, no need to swap. 66 and 52, we need to swap. And 66 and 90 don't need to swap. Then that is the end of the second pass. You write out the numbers and their final format. Because the list is still not in the correct order, what we need to do is do a third pass, and you'll notice that the first two numbers need to swap, but then after that there are no more swaps. So at the end of the third pass, the items are now in the correct order. So the obvious advantages of bubble sort is it's a pretty simple algorithm to program. Essentially, you're just comparing two values and swapping them if they're not in the correct order, and if they are, then you just pass to the next one. It's quite an efficient way to check if something is in order in the first place. So at the end of the first pass, you can tell if something's in the correct order or not. Disadvantage of bubble sort is it's pretty inconvenient, as you always need to do at least one pass. Disadvantage as well is that it doesn't cope well with large lists, so you're going to end up doing a lot of iterations of the bubble sort. So insertion sort is one of the easiest sorting algorithms. Essentially what you do is you start by looking at the second item in the list, and you compare it to the items to the left and insert it into the right place. So if it needs to move to the start of the list, you could swap it, otherwise you leave it where it is. And you keep doing that by moving along to the right. So you start with the second item, then you'd look at the third item and the fourth item and the fifth item, and you only move it into the right place if it needs to move to the left. So let's look at an example. Makes it really easy. Using insertion sort, put these words in alphabetical order. So in other words, A to Z. So we look at these words and we go, right, hang on a second. What do we need to do? Write out the words. Check the second word along, which is story. And does story need to move to the left? Can it move in before balloon? No. So that doesn't insert. So you write in no insertion. Then you look at the next word along in the list, which is pillow. Does pillow need to move to the left? Yeah, it needs to go before S. So you move pillow before S. Then you look at the next item in the list and you compare it to everything to the left and it doesn't need to move. Then we do score, that needs to move. We do knife, that needs to move. And we do reverend, that needs to move. That basically puts all the items in the correct order. As you can see, it was pretty quick, relatively easy to do and pretty easy to code. The best way of remembering this and getting it right, I think, is to imagine a pointer, and the pointer is moving up by one as you do each line. So for the start, the pointer points to story, and then on the next line, the pointer moves to pillow, and then the next line, pointer moves to toad, and so on and so on and so on until you get to the end of the list. So the obvious way of using insertion sort is it's a pretty intuitive way of sorting things. It's essentially what you do when you get a pack of cards and you're playing poker. You get dealt your hand, you've got your 5 cards that you need to sort, and you start from the left and you put them into the right section as you go along. It's intuitive and it's pretty simple. It's very easy to code and it's very, very quick if you've got a small list of data. The disadvantage is it doesn't work very well with large lists of data. It's going to take some time to process all of the data as you go through. So the last sorting algorithm is merge sort. Merge sort essentially splits the list in half as it goes down, and you basically keep splitting and splitting and splitting until you get all items on their own. When you've got all the separate items, you start to merge the pairs back up again into the right order as you go. And essentially you just keep repeating the merge steps until you've merged all of the sublists into one. So the merge sort example might be tricky to follow at first, but if you take your time from the top, it should make sense. So we start with our list of data. I've chosen letters just to make it easier, but they could be words or numbers. So essentially what you do is you split the data into 2, or as close to 2 as you can get. If it's an odd number, then you could split it into 4 and a 5 or something instead. And then you split it again and split it again until you end up having individual pieces. So you can see that it splits from 8 to 4 to 2 to 1. When you've got all your individual lists like we have here, G, N, B, M, U, E, J, I in the middle, then we need to begin to merge them back in the right order. So you're only looking at 2 values at once. We're looking at G and N and we're merging them into the right order, which they already are. B and M already are. U and E need to swap, so when we merge we put them into the right order. And J and I need to swap, so when we merge we put them into the right order. Then you do the same process again from taking the 2 pairs and putting them into the correct order. So you put B, G, M and N in the right order. Then you put E, I, J and U in the right order. And then the last step is to merge them all into the right place. And you'll notice that that gets a lot easier as you go through the merge steps. On the actual exam, you get marks just for showing the merge steps. So if you just write the data out in individual pieces and show the merge steps, you can still get full marks without showing the splits. So the advantage of using merge sort is that it's more efficient. Essentially, it's quicker for large lists and it's very consistent running time. It seems to take a very consistent amount of time no matter how big your list is. Disadvantage is it is slower if you use a very small list. You could definitely sort it quicker using linear using insertion sort. Another disadvantage is it still goes through the whole process even if the list is already in the right order. Another disadvantage is it uses more memory because you need a separate memory location to separate all of the list items into. So looking at this particular website here, I'll put the link in the description, This is sorting algorithms animations. So you can see all different types of sorting algorithms. The ones that we've done are bubble, insertion and merge, and you can see those three there. Now when I press play all, it will sort these lists of data into the right order, and you can see the difference in speed between them. So when I press play all, you'll notice insertion, bubble and merge run at different speeds, and you can just have a look and see which one you think the quickest is. So we can see them going. Merge sort's finished, then insertion, and bubble is still going, and now it's finished. So if we try that again, just watch closely. Merge sort is done now, then insertion, and then bubble. So we can see which one's quicker and which one works a lot better than the others. That brings you to the end of the sorting algorithms video.